So what you see in this slide is an instruction format of 8086 microprocessor. You can see this is an 16-bit instruction format. Your assembly instructions will be converted into a machine instruction, and that machine instruction format is the one which is shown here. You can see the first 6 bits. These first 6 bits are going to be an opcode bits. You can see this 1 0 0 0 1 0. The various combinations of these 6 bits can give you different opcodes. Like you have move, add, all those are called as opcodes. The next bit to opcode is D bit, and you can see what the D bit is telling you. If D is equal to 0, then you have the direction from the register, that the data which you are getting, it is coming from the register. Similarly, if the direction bit is to the register, then D bit will be 1. This you can better understand by using an example. Similarly, if the data which you are handling using this instruction is a byte, then this W will be 0. If it is a word, that is 16-bit, then it is going to be 1. And you have this mode bits, 2 are mode bits, and this is register bits, and this is register memory bits. Now these mode bits and register bits and register bar memory bits can be seen from these tables. This is your register, and these are all combinations for various registers. All these are various combinations for various registers, and you can see this mode bits and register bar memory bits. These are all the bits available for various types of addressing modes and various types of registers. You may not understand this until we solve one example. This is for 32-bit. So let us take an example for an instance. We will try to convert an instruction move AX, BX into machine instruction. We convert one move AX, BX, one instruction called as move AX, BX into machine instruction. So the first we need to know about this instruction. What this instruction does? This instruction will transfer the content of the BX register. It will transfer the content of the BX register to AX register. So now you can consider it in 2 ways. This instruction can be considered in 2 ways. One is you are transferring from register to register. You are transferring to the register. Also, the second case, you can also consider transferring from the register. You can have first case is transferring to the register. Second case is transferring from the register. Both can be considered. So let us start with the instruction format. Let us come here Let us take 8086 instruction format. So first the move instruction. Let the move instruction be 10000010 and D direction, D bit. So D bit is, let us consider now first case as direction to the register. So when direction to the register, this will become 1. This will become 1. And here you can see we are using AX BX register. So that means we are using data word. Data word means this is once again 1. 1. Now let us see what is mode bit. And register, here you can see you are transferring to the register. Right? You are transferring to the register. So that to register combination bits you are supposed to put it here in this register. So which is the register it is transferring? So we have move, instruction move AX comma BX. Which is the register it is transferring? It is transferring to register AX. So what is that register? That register will come here. So what is the combination for bit combination for AX? Which you can see here from the table which is given here. This is the table you can see. For AX register it is 0000. You can see here. This is 0000. Right? 000. Now what you do now? You just put that here. Just put that here. Here comes your 0 0 0 0. Now let us see what is mode bits and register. So here you are actually transferring from a register. So this is going to happen. Right? So let us go to the mode register memory table. That register memory table we need to have it with you. This will be given in the examination. See here. Now here it is a register. Right. So this is the register. Since it is a register, your mode bit, say this is the register. We are using only registers. Since these are all memory. These are all memory. You can see that square bracket, its memory contents. Now, because we are going to use the register here, okay, this is W is equal to 1, W is equal to 0. You see this is for byte, this is for word. Now register, from which register data is coming? From BX register. And it is only register, so mode bit will be 1 1. Mode bit will be 1 1. And register, that is BX register. So BX will be correspondingly R by M will be BX. This is 0 1 1. Now mode is 1 1. Register bar memory is 0 1 1. Now let us put that 1 1 and 0 1 1 here. Okay. So this will be 1. This will be 1 1 and this will be 0 1 1. This we have taken as 0 0 0. This will be 1. This will be 1. Fine. Now what is the machine instruction corresponding to this move AX comma BX? Now see, you make all these are the machine instruction. So how do you represent it in the hexadecimal format? You take this 4 bits like this. This is what? This is 8 and this one 1011. This is actually 8 plus 2 11. 11 is B and this is 12 C and this is 3. 8B C 3. Right? This is 8 plus 4, 12. Okay, this is 8b, c,